Hello and good afternoon. My name is Paul Chisano, and I'm pleased to welcome everyone to the next presentation in the Precision Roll Grinders webinar series. Our topic today is barring in calendar rolls. The length of this presentation is about 15 minutes. Everyone is on mute right now. There is a chat function if you have a question. Please feel free to ask that in chat. And at the end, if you like, I can unmute everyone and you can ask your question that way also. So with that, I am going to go ahead and get started talking about barring in calendar rolls. So the first question here that you might be asking yourself, why should I care about barring in calendar rolls? Well, it's a great question. And the reason you should care is because barring has a significant negative impact on paper properties, maintenance spending, the frequency that you have to change your calendar rolls, paper rejects related to barring, and the biggest impact, which not everyone thinks about, is barring in calendar rolls can have a negative impact on fiber usage on the paper machine. So what impact does barring have on paper making? Well, barring causes variation in the machine direction caliper of the paper. Barring causes variation in the strength of the paper, also in the machine direction. Barring causes paper rejects related to reel building and winder runnability issues. And once again, barring can cause you to have to use more fiber usage on the paper machine. And I'll talk more about that in coming slides. Okay, well, what if you're not a paper maker? What if you're in maintenance? What impact does barring have on maintenance? Well, barring causes excessive vibration, reduced roll bearing life, and you have to change your calendar rolls more frequently if you have barring. And more frequent roll change causes increased labor costs to change the rolls, higher expense to have the rolls serviced. It reduces the life of your calendar roll. If you have to grind it more often and take more metal off, that's going to reduce your roll life. And the biggest financial impact of frequent roll changes is the paper machine downtime to change the rolls. It takes many hours to change the rolls, and obviously you're not making paper during that time. So that's the impact that barring has on paper making and maintenance. Well, what exactly is barring anyway? Well, barring is axial lines, also called bars, of non-uniform hardness in the calendar roll surface. And this is a key fact here, the peaks are harder than the valleys. And that's really important because as the roll continues to wear, the valleys, because they're slightly softer, they will wear more than the peaks. And so the peaks will get higher or the valleys will get lower. It's also important when you go to grind the roll because you want to grind away the peaks, but because the peaks are harder, it's possible that your grinding operation will remove more from the valleys than the peaks. So it can be very difficult to properly grind a roll with barring. The peaks are evenly spaced around the roll circumference. They're a harmonic of the roll. And if you were to put a measuring device on the roll and rotate the roll, it would make a signal similar to the graph shown on this page. So that's what barring is, non-uniform hardness. And the peaks are harder than the valleys. Very often, barring is not visible. But one way to reveal it is with the lead test. So this is a photograph of a calendar roll that was freshly ground by others. And if you look at the left side of the photo, that roll surface looks freshly ground and it looks very good. In the center of the screen, a sheet of lead was rubbed against the roll surface, and the soft lead adhered to the high spots. And so it made the barring visible. So even after this roll was ground, the barring was still present, and the barring was not visible until the lead test revealed it. So barring is often not visible. Another way to detect barring is with a precise TIR measurement. And so there's a polar plot, and I'm sure many of you have seen these. Once again, this is a roll that was freshly ground by others. Even after grinding, this roll still has barring, and the precise TIR measurement shows this. The amplitude of these peaks is approximately 80 millionths to 120 millionths of an inch in this particular example. Those are really small numbers. The spacing on this graph is 1/10,000th of an inch. Every line represents 1/10,000th of an inch. So when you look at a similar graph, note the scale, because the resolution of the instrument and the scale of the plot has a big impact on the appearance of the graph. So a precise TIR measurement is the second way to look for barring. Another way to detect barring, and this is really simple, is with nip impression paper. If you roll the nip impression paper through the calendar stack in the machine direction, it will detect the high and low places in the roll. A really simple, easy test to do. And then a fourth way to detect it, and maybe some of you have seen this before, if the barring is severe, it causes radial lines to appear in the side of the reel of paper. And why is that? Well, the spacing of the caliper variation in the paper, when it becomes a multiple of the real circumference, these hard and soft lines will appear. And these hard and soft lines can result in paper rejects at the reel, at the winder, and poor runnability at the winder, and also at converting operations, printing and or corrugating plant, for instance. So that's another way to look for barring if it's really severe. Okay, so we talked about the impact of barring and 4 different ways to look for it. Well, what causes barring? Well, the answer is vibration causes barring. But the vibration has to be a harmonic of the roll rotational speed. And I assume you know what harmonic means. It's a multiple of the roll speed. For instance, 2 times the roll speed, 3 times the roll speed, 12 times the roll speed, 36 times the roll speed. And so if the vibration is harmonic, it will impact the roll in the same location every revolution. And so that spot that's getting impacted will become work hardened. It's kind of like bending a paper clip. It becomes more brittle and harder due to that working. And so that's why the peaks become harder than the valleys, is because of work hardening. Okay, so vibration causes barring. What causes vibration? Lots of things, of course. Bearing issues can cause it. Drive coupling issues can cause vibration. If you're running your roll close to the semi-critical speed, the natural frequency of the roll, or half the natural frequency, that can cause vibration. The paper web can cause vibration if there's periodic thickness variation in the paper web. And what might cause that? If you have pulsations at the head box, fan pump vane pass frequency, if it happens to be a harmonic of the roll rotational speed. Same thing with a centrifugal screen, the bar pass frequency. It can cause a pressure pulse, can show up in the paper web. and it can influence the calendar roll. Impurities in the stock, particularly if you're running OCC, impurities are common, and if it can cause vibration in the calendar stack when those impurities go through the nip. But the biggest cause is rolls that are not properly ground. And by that I mean rolls that had barring, but when they were ground, the barring was not completely removed. Because once the roll has barring, it generates its own vibration, and that vibration will be harmonic. So once you have barring in a roll, it will not go away until it's completely ground out, which again is not easy to do. Barring spreads. If the paper is marked by some vibration in the first nip, that mark will cause vibration in subsequent nips. And if that vibration is a harmonic of the roll rotational speed, then barring starts. So if you have barring in one roll in your calendar stack, it's very likely it will transfer to other rolls in the calendar stack. It's one reason why it's important, if you have barring, to grind all the rolls and change the rolls as a complete set. You'd hate to grind one roll and put it back in and then it quickly become barred due to the mating roll having barring. So barring spreads. This is a real world measurement of a sheet of paper showing MD caliper variation. And they took really high resolution measurements, really precise, and they spaced them very close together. In this example, the amplitude of the MD caliper variation is 400 to 600 millionths of an inch. Another way to say that is 4 10,000ths of an inch or 6 10,000ths of an inch. So these are really small numbers. The caliper variation in the paper is very small. In this particular example, the peaks are spaced 2.1 inches apart in the machine direction. And normally the online scanner and the quality lab don't measure the caliper that closely unless they make a special effort to do so. So it's possible to have this MD caliper variation and not be aware of it with your normal measurements. The barring causes MD caliper variation. MD caliper variation in turn causes MD strength variation. So here is another real world measurement. It's not the same example, but it's a similar one where the paper was measured in the machine direction. In this example, the MD caliper variation is 4 10,000ths to 6 10,000ths of an inch. Very small numbers again. The corresponding MD strength variation is 20%. So the areas with low caliper also have low strength. It's kind of like the weak link in a chain. So those low caliper areas have less strength than the surrounding areas. And this is data that was done in a study by an organization called FP Innovations or Forest Product Innovations. So what very often happens is, you have a minimum strength requirement on the paper. So in order to meet that minimum strength requirement, it can be necessary to add extra paper fiber to get your strength up to target, up to minimum. If you add extra fiber, then of course you have to dry that fiber. You have to use more steam. Maybe you have to slow down. So this can be a huge impact from calendar roll barring. Tiny little numbers like 4 10,000ths of an inch can add up to a big economic impact. If you grind your rolls to a precision grinding tolerance, the barring can be eliminated. So here's an example. This customer switched to precision grinding tolerances. PRG ground their calendar rolls. Barring was eliminated. Their MD caliper variation improved significantly. And you can see it in the photos. The radial lines are now gone from the side of the reel. They documented that they were saving 250 pounds of paper at each turnup, which conservatively comes out to $300,000 a year just in spool losses. Breaks at the winder have also gone down significantly. So this can be a significant financial impact on the operation that you may not think about. Okay, so just to summarize, tell me again, why should I care about calendar roll barring? Because barring affects paper properties, maintenance spending, roll change frequency, paper rejects, and a really big hitter can be fiber usage can go up due to calendar roll barring. So that's great. You might be asking yourself then, what can I do about calendar roll barring? Well, one is specify very tight tolerances for your calendar roll grinds, knowing that barring peaks can be very small and still have a large impact on paper properties. The second thing you can do is insist that barring be removed during grinding. It seems obvious, but if you don't bring it to the attention of your grinding provider, you may not necessarily get that. So insist that it be removed. And then the third thing is look for it to confirm that it is removed. And we talked about 4 different ways to look for it. One is the lead test. One is a precise TIR measurement, nip impressions taken in the machine direction, and looking at the side of the reel. 4 different ways to look for barring. So specify tight tolerances, insist that barring be removed, and look for barring to confirm it's gone. At Precision Roll Grinders, we guarantee to you and to all of our customers that if you let us grind your roll, we will return it to you with no feed lines, no chatter, and no barring. Guaranteed. Thank you for making time to participate in this webinar. And this would be a great time if you have any questions. I'm going to see if I can unmute. Or feel free to use the chat function if you want to ask a question that way. It doesn't seem like I have any questions in the chat. So I am going to go ahead and say thank you for attending. If you have any questions, you could always reach out to precisionrollgrinders.com, and we would be happy to get back to you on that. Thank you again for attending. Have a good afternoon, everyone.